Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim SYAHMI bin Muhammad Yusuf. My matrix number is DE210091. Okay, so today we will present our group project for BEV20203, which is Transform Circuit Subject. Okay, our project title is Analyze the Linear Circuit. The question given to our group is question 1. Okay, we are from group 4, section 2. Our group consists of 3 members, which is the first member is me, Muhammad Hazim SYAHMI bin Muhammad Yusuf. The second member is Muhammad FARID bin SHAMSUL KAHAR. And the third member is Muhammad Hazieq AHNAF bin ROSNEI. Okay, in this video, we will present our circuit based on question 1, the manual calculation to find the voltage output, the simulation that we do in MATLAB based on question 1, and the comparison discussion.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazieq bin ROSNEI. My matric number DE210068. Okay, in Transform Circuit Project, I will present about manual calculation of analysis the linear circuit. Okay, this is a circuit in time domain and we convert it to the frequency domain. As we can see, we have 10 over S plus 1, we have the inductor S, we have the capacitor 1 over 2S and 4 ohm, and the current is 3 over S. Okay, we go to the manual calculation. First, we have to find the V out T of the circuit. Okay, to start the manual calculation, we apply the nodal analysis to the S domain DOM of the circuit, and we will get this equation. Okay, as we can see, here is the voltage, and this S is the inductor. 3 over S is the current, the V out over 4 is the resistor, and then 2S V out is the capacitor. And then we have to, next we have to move the V out on the left side to the right side like this, and we multiply all the equation with S and we will get this equation, and we take out the V out like this, and we will have V equal to 13 plus 3S over S plus 1 and 2S square plus 1 over 4S plus 1. After we change to the equation 1, we will multiply A with the 2S square plus 1 over 4S plus 1, and BS multiply by S plus 1, and C multiply S plus 1, and we will get this number. Next, we assume all S in this number as -1, 0 and 1, and we will get S assume -1 like this. And after we solve the number, and we will get A equal to 40 over 11, and we will get C equal to 103 over 11, B equal to -80 over 11. And then to make it simple, our Laplace, we have to split all the A, B and C to 3 numbers, and we will get the answer of Laplace as V out T equal 40 over 11 exponent -t minus 80 over 11 exponent -0.0625 t cos 0.704 plus 100t over 11 exponent -0.0625 t sin 0.704. Okay, next question is we change the Vs equal to 50, and then we apply the nodal analysis to the S domain, same as the first circuit we have, and the calculation is not very different from the first one we did. The difference is here 53 plus 3 but the first one is 13 plus 3, and the next difference is here. At the value of A, C and B. As we can see, the value is different from the first circuit, and we have here A equal to 200 over 11, C equal to 543 over 11, and B equal to negative 280 over 11. And all value of A, B, C we insert into the equation 1, and then we Laplace the equation, and we will get the answer of Laplace as V out t equal to 200 over 11 exponent negative t minus 280 over 11 exponent negative 0.0625 cos 0.704 plus 543 over 11 exponent negative 0.0625 sin 0.704. Okay, that's all the manual calculation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FARID bin SHAMSUL and my number metric is DE21003. So today I will make a video presentation for the simulation transform circuit group assignment project. So the simulation that I use is MATLAB. We need to set up this circuit figure Q1 into the MATLAB. So this is the MATLAB. I already done the circuit, so we need to set up all the resource, the inductance, the capacitor and also the resistance. So we already set up the DC voltage source for 10, the inductance 1, the capacitor 2, and also resistance 4. Okay, next we need to put the voltage sensor and put the ground and the display so that the values for when we run will be displayed here. So we will run for the 10 voltage source. And as you can see, this is the voltage when we put the resource is 10. So next we need to determine the VO in the circuit if the resource is 50. So we need to change the resource with 50, and then we will run again. So this is the value that we will get when we change the resource from 10 to 50. That's all from me for the simulation. Thank you.
Okay, so next is the comparison discussion. Okay, the first comparison is the comparison between result A and result B. Okay, so this table show the result that we get for A and B from manual calculation. Okay, as we can see, the voltage output that we get when the voltage supply is 50 power of E minus T volt is 18.47712 volt, which is higher than the value of voltage output that we get when the voltage supply is 10 power of E minus T volt, which is 1.82342 volt. Okay, so I will explain about the difference between the result. Okay, the circuit used for both question, which is A and B, is the same. So the value of variable such as resistor, inductor and capacitor will remain the same. Okay, the only difference is the value of voltage supply that goes into both circuit. Okay, so the conclusion that we get from this comparison is when the voltage supply increase, the voltage output will also increase. Okay, the last one is the comparison between the manual calculation and simulation in MATLAB. Okay, so this is the table of the result for manual calculation and simulation. Okay, so based on our calculation, the value of voltage output that we get from manual calculation for voltage supply of 10 power of E minus T volt is 1.82342 volt. Okay, while the value of voltage output that we get from the simulation in MATLAB is 3.421 volt. Okay, so next, for voltage supply of 50 power of E minus T volt, the value of voltage output from manual calculation that we get is 18.47712, while from the simulation in MATLAB, the value that we get is 20.25. Okay, so what can we conclude is the voltage output that we get from manual calculation and simulation for both voltage supply is quite close to get the same value. The difference between the value of voltage output can be due to the difference in decimal point for manual calculation and simulation, or maybe software error in MATLAB software. So that's all from us. Thank you.